First of all, I want to thank you all for coming. I think, personally, you guys are the smartest people in this whole conference, right? Because you have a choice of going to all these other sessions, and you decided to come here. That makes you the smartest cookies in town, and I want to thank you for it, right? So, I'm here to present something called the Big Data Toolkit. And this is going to be very technical, very deep. We're going to be showing code. We're going to be showing what I call HOCONs. HOCON stands for Human Optimized Configuration, which is actually what we're going to be spending a lot of time on. And then I'm going to be doing a lot of tablet work too, so there's going to be a lot of hand drawing and stuff like that. And I am very proud to be with my friend Kunam. Kunam, introduce yourself.
Hi, my name is Kunam Kim. I work with Mansoor on this Big Data Toolkit, and we both are in professional services in Esri. Thank you.
So also I'm with professional services. I've been with the Esri 20 plus, more than 20. It's going to be almost 24 years. We built several products at the Esri. Anybody use ArcGIS? That's, of course, right. You're not allowed to raise your hand. You're not. So that was one of my silicon babies. The Flex API was my baby, right? The ArcWeb was my baby. And as you can see, everything I touch dies, right? So this guy, 5 years from now, is not going to exist anymore because he's going to be dead. I'm kidding. Hopefully not, right? Hopefully not. So it's pretty cool. So a quick survey: who has big data? Who has truly like big data and like storage, compute, and stuff like that? Like who has like a Hadoop cluster or something like that? Okay. Who uses like Hive, HDFS all day long, right? Who uses Spark? Okay, good. Spark. Who uses like Elasticsearch, Cassandra, HBase? I'm like rattling name. I want to see what's going on. Okay. Actually, despite that I went through all these names, you do not have to have a big data environment like a Hadoop cluster or anything like that to do what you need to do. There's one animal that I need in the zoo, and we're going to talk a little bit about it here, which is Spark, that needs to do that. Practically, a lot of things that you can do is because you've been having problem in traditional means, right? And you want to solve it in new ways. And actually, this is my definition of big data. Right? Traditional means are failing you, and you're looking for new ways to do things, right? And so yes, there is the typical volume, velocity, and variety, right? And that is the official definition of big data. But what I find, that is not what it is. For me, it is the traditional cases are failing you, and you need new ways to do it. And what I believe is we need to do it is we don't need to do it in a big data cluster. You should be able to do some of these problems on your laptops if you have them big enough to do what you need to do. And modern computers are so amazing that we should be able to do that. So again, this is a technical dive onto the Big Data Toolkit. And first of all, let's describe what the Big Data Toolkit, and I think it's very, 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 very important. This is not a product from Esri, okay? It's not a capital P product from Esri. Big Data Toolkit right now, as it stands, is a soft solution from professional services. What does it mean is when you want to do big data, when you want to use the Big Data Toolkit, you need to engage us, we in professional services, like Kunam or me or some people on our team, to help you with that. And what we do, what we bring in is a set of software application that is based on years of experience. We've been doing this big data literally from the days of Hadoop, when literally Hadoop started back in MapReduce days, and we've migrated all along to Spark and stuff like that. So what you're seeing is truly in the trench ways of doing things. We did not went ahead and we did not go around and say, okay, we're going to solve all the world's geospatial problem, right? We found out what people are really doing it, what are people having problem with, and that's what we tackled with. And actually what we find out a lot is not GIS people that have problems, it's actually IT people that have problems, right? So it's actually more, this thing is not intended for people that do GIS, is for IT people that want to do spatial stuff, right? Now, for we in this room here where we are, when we're like, what's the difference? Well, for us, when we look at, when we want to do analysis stuff like we do hotspots, right? Versus the IT guys, they do heat maps, right? For us, GIS, there is a difference between hotspot and heat maps, right? But for the other guys, they don't care because they just want to interested in seeing red dots and stuff like that, right? But for us, like, what do you mean red dots? It doesn't mean anything. We need to do spatial. We need to make it statistically significant. That's why we call it hotspots, right? And that's the difference for us. But for these guys, I just want to see hotspots, right? They don't care. They just, I want to see this density of data that I'm not able to see and stuff like that. And what we've done, we've taken some of these hard algorithms that we've been doing, like spatial join, heat hotspots, and not hotspot, heat maps, and proximity analysis, some of the things that these guys wanted to do all the time. And what we did is we literally implemented in parallel distributed way, and we were able to, and we delivered this as a solution. Another thing that these big customers have, they have their data in their environment. Typically, you had to move the data from big data environment to a GIS environment to be able to do anything. So, well, that's fine if the data is small, you know, maybe you have a million, couple of million records, you can do that. But when we have on the left-hand side, what I call the left-hand side is the big data guys, and they have millions of points. You cannot take the data and move it to the other side. What you want to do is you want to operate on the data in their environment, right? And more importantly, today, they take the data, and despite they want to do it here, they want to keep the result back into their environment. Why? Because they have other assets, other entities that are interested in the derivative of what you want to do. So actually putting the data in ArcGIS does not make sense. They want to take the data from their environment, run it in their environment, and put it back into put the derivative back into their environment, right? So this is very, very important for them. And another thing, they come up to me and says, Mansour, I invested hundreds of thousands of dollars in this cluster. I have a 500 node cluster. Why can't you take advantage of that cluster for me? So run that analysis on this cluster that I allocated data on, I allocated resources on, right? Run it in it, take my data, dump it back into me, right? So this is basically the premise. This is the big premise that actually where Big Data Toolkit comes in. I've made this investment in this hardware that I have, right? So a telco or an insurance or an oil and gas, right? They've made this investment, they've been using it. Take advantage of that resource, take the data from my environment, dump it back into me. Make sense, everybody? And this is what we see all the time. And we've been lacking as a solution for that, and we'll be able to implement that Big Data Toolkit. So again, people that have their own data lake, right? They have something very important. This is the only animal that I require in the zoo. They need to have Apache Spark 2.0. Okay, that is the only animal that I need from the zoo. By the way, because there is Apache Spark, that does not mean they have to have Hadoop. They're not synonymous with each other. Yes, a Hadoop distribution will come with Spark, but I can go to a lot of places. We go to a lot of places where we have a Spark instance, and we don't even mention the word Hadoop. We don't even mention the word Hadoop in there, right? But we need a parallel way to do distributed computing. Again, no data movement to AGS. I know, because we think about ourselves as the center of the universe and everything has to be in AGS, but actually that's not what they want. And they want to put back their data in environment. And I don't need to know GIS. I just need to do some things that make sense to me. So with that in mind, we've been doing this for quite some time with oil and gas, where we bring in telemetry data, right? Oil and gas telemetry. We've been on on their wells, on their tankers, on their tracking, the GPS breadcrumbs. Telco heavily uses us for drop call analysis, right? That is a huge one, right? How do I do a drop call analysis at 100 meter for the whole United States, right? And then do this effectively, reliably, and then give me that insight that I'm looking for. Insurance now are starting to put in this little ODB right into the car, right? I don't know if you know that, but they can start, they do a lot of that. Manufacturers, car manufacturers are not interested in data from to push out telemetry, but they're interested to car-to-car navigation, which is very interesting. Of course, intelligence, we've been doing a lot of intelligence work to track bad guys, right? And more scenarios that's coming in here. The Big Data Toolkit is built on the following stack, okay? Down at the bowels of it is made of the Esri core geometry library, okay? And you'll notice something very interesting here, right? No source code, right? We don't give you source code for that one. On top of it comes the Bdt executor. Again, it's for managing of licenses and stuff like that. There's no license manager, but there's a license file that you have to execute. On top of that comes two important things that I'm going to be talking about a lot here today, is the Bdt API, which is basically a concept that we have a concept of source processor sync, and the SDK, which is the implementation of that API. Now notice, ladies and gentlemen, when the solution comes in, if you're interested in the solution, the source code for these is a private GitHub repo that if you pay and play, you can see all the source code that we give you here, right? So there's no source code here down below, but these two things, we do that. And of course, on top of that, you can build, because you have access to the API, you can build your own custom specific implementation of a sync processor or whatever it is, or a source. And of course comes with bunch of, we have to hook it up all the way to ArcGIS. It comes also with a bunch of toolboxes, all written in Python to enable us to move the data, look at data and stuff like that, which is what we're going to be doing here. Okay? So internally, as I said, very, very important, we do not bring in our own Spark. Right? You have to have your own Spark. Now, if you want to help you install a Spark instance because you don't want to do that because this is important, fine. But typically, when we go to places that need something like that, they have already a Spark 2 in there. The API and the SDK is written in Scala because Scala is the language for Apache Spark, right? So we decided to use Scala for that. That does not mean you cannot use something we call PySpark if you're familiar with that, okay? If you're familiar with PySpark, you can use that API because the folks that the Databricks guys abstracted that from us. And finally, we build it. If you're going to be building the source code, we use Apache Maven for you guys to know. And the toolboxes that comes with the Bdt key is all based on Pro. And you need basically ArcPy and Python 3 to be able to do that. But all the toolbox that were written are pure Python, and we did that on purpose because the best way to extend, as you heard from Jim talking a couple of days ago, the best way to extend the ArcGIS platform is through Python. And we deeply believe in that. And it's really easy, it's very simple, and guess what? There's a lot of tools that will come with that. And we'll talk more about it in here. Again, you have access to the private repo if you believe in the architecture, and you can see, so, and then of course no core source code, which of course which makes sense perfectly. Again, so what is big data, right? In big data, you break up the paradigm, right? In the old days, data has to come to the program, right? Data comes to the program. When you open up, for example, ArcGIS, you load a shapefile. When you open up Pro, you load the shapefile into ArcGIS Pro, right? So data comes to the program to do whatever it is. Well, guess what? If I have billions of records, you cannot bring in a billion records into your application. So in big data, we shift the paradigm around, and the program goes to the data, right? Program goes to data. And how do we do that? This is for geeks. The IT guys love this. Why? Because literally I'm giving them the command line interface, Spark submit. Anybody familiar with Spark? Okay, if you're familiar with Spark, you love this because this is what you have to do. You literally open up a CLI, Spark, submit, and you pass in the Bdt.jar. And when you Spark submit the Bdt.jar, you literally take the jar and it gets copied to every worker on the edges. And depending on your data source, it will operate on that data source when it comes along with it. So it can be Cosmos, S3, Elasticsearch, Cassandra, Hive, Hadoop, whatever it is that Spark supports. Typically, a lot of these guys, the data vendors down here, the storage people that are providing this, practically all of them already have drivers for Spark to be able to go on with it. So when you submit the Spark job, there's a lot of things built into here, but you can actually give the jar of a specific vendor that you want to go into. It gets complemented and gets sent down to the engine to execute in parallel distributed way, right? That's what makes Spark so amazing. And guess what? This does not have to be on, I'm showing you a cloud or a local or a big data infrastructure, but a lot of the times, guess what? I can do a lot on my laptop amazingly fast if I have the correct architecture. Well, once the data is like 15 million points, right? I can still do it here, not bad. But after that, then we have issues and I need to go up to the cloud or big cluster to do that. You can execute it from command line, which is what we're going to be doing a lot today. Actually, Kunam, what did we instantiate? We instantiated an Azure instance.
So
Tell
for
us.
today's demo, we are using Azure HD Insight that has 5 workers. and each worker has 16 cores with 100 gigabytes.
Yeah. Okay, so this was easy for us to instantiate up in the cloud. We put the jar up there. We're going to be ready to use it. And typically today, we're going to be using the Spark submit code to do that. There is a web application called Livy that if you want to, you can use that. Some of you guys that are on site have that application. You can use it from a ArcGIS toolbox if need be. And more importantly, this is where we're going to be spending a lot of time on today. I want to show you. You do not need to know Scala, nor you need to know, everything is fully configurable. Right? So what we did is we abstracted everything from you guys. We took all the hard work, we already built it, and now you just configure. If you wanna build in your own stuff, guess what? You can do that, right? You can take the Scala code and start doing it. And the DBTT components typically is the following you have to know. These are the basically fundamental 5 classes and traits that you have to know. Right? Very simple stuff. And they follow very much the Esri way of thinking. So you have a feature class, a source, a processor, and a sink. A feature is this, right? So we use the Esri geometry, internal geometry API, and we use the Spark SQL row interface. So a feature has geometry and attributes. Duh, right? This is classic Esri stuff, right? There's nothing magical about that. Okay, so it's very simple. So if you, anything can be expressed as a geometry, which is, by the way, is the superclass for points, lines, and polygons. Of course, I'm not going to explain that to you guys, right? Any attribute can be expressed as a row. Now, something very interesting in this row here, this is not just a map of a attribute to a key. This could be a map to a map to a map to a map. So you can come up with attributes that are very, very complex attribute, very nested. Now, typically in the Esri parlant, an attribute is a map, a row is a map, which is a key and a value, typically, but you do not have to have that. It can be nested because that support rows of rows of rows of rows of rows if need be. Okay, very powerful concept. Despite that some of the data sources do not support that, there are other data sources that do support that, like an elastic document, for example. If you bring an elastic document, it can support that nested structure in there. A feature class. What's a feature class? It's nothing but a collection of features. So in a feature, a collection, in the Spark parlant is called an RDD. Now you're saying to me, why did we not do data frames? Actually, we've been thinking about that, but we built this way before data frames were ubiquitous and everything like that. So right now we stuck with RDD. RDD stands for resilient distributed, what's RDD stand? Data set, thank you. Resilient distributed data set. And literally it's made up of the collection of feature and of course the schema of that data, right? Next, a source. A source is a trait. In the Java parlant, a trait is an interface, by the way, okay? And as you notice, it's very simple, right? You just have to implement the read method. That's it. You implement the read method with that function, and if you can return me a feature class, now you can build in whatever it is you want. So what we've done, we've built a bunch of sources for you. CSV, JSON, TSV, not Cassandra, SQL. I'm going to show you the list, right? So this is the basic source trait that we have. Next, async. Async, again, is another trait where, again, if you can implement the right function, it takes a Spark session and a bunch of sources, and you just have to implement the meat of that one, and you can now write data to it. Notice, you can write multiple sources into it, and so thing. And finally, the glue between them, a processor. A processor sits between a source and a sink. Does actually, you do not have to. A source can go directly to a sink. But if you want to do something with the data, you just have to implement the processor, which it's a process. It takes a bunch of source. Whatever you do with the implementation, your decision, and returns one or more output. An input can produce multiple, a processor can produce multiple outputs, okay? So this is why it's there, okay? And it can take multiple inputs to produce multiple output. That's why we have the maps in here, and you'll understand why it's a named feature class. We're gonna talk about that, and you'll see that in a little bit here. So a bunch of sources can be, they're batch only in this implementation. There's no streaming, by the way, FYI, right? You wanna do streaming, use GeoEvent or IoT or something like that. We don't do streaming. Okay, very important. The protocols, practically everything that Spark support. File, S3, HDFS, JDBC, Azure Blob, Elasticsearch, right? And more are coming. And if you don't like it, basically you build your own, right? And then the formats is CSV, JSON, TSV, Parquet, Avro, imagery. Pick whatever format you have. As long as Spark supports it, it's right there. You can do it. Async. Same thing, you write the data out. It can write to file, to HDFS, to S3, to Elastic, to Kafka, whatever it is support, and the format, all the formats that are practically in there that Spark support, and if you want, you can build your own from there. We're going to talk about the processors. This is where we're going to be spending a lot of our time on, how to configure these. So we've taken, as you notice, ArcGIS has over 300 geoprocessing tasks, right? We did not take all the geoprocessing tasks and turn them into Spark distributed jobs. We took the hard ones that you guys, the IT guys, are having problem with, which is what? The first one, that everybody comes up to me, spatial join. How do I join a billion point by another billion point, Mansoor, right? Without spatial index. That's very important. Did you hear me? I have data, I have big data, right? That's just there. I have no concept of indexing. I cannot index a billion points coming in at me, right? How do I spatially join it with another billion points and do it today, not tomorrow, right? Not come back tomorrow for it. How do I project, buffer? Point and polygon is what we see a lot, right? A bunch of polygons all over the place, territory, I have billion points. I want to do aggregation by polygon, how to do that. Near attribute within filtering data, add fields, of course, we have to do that easily, but then we've taken it up one level, right? We've done something like, for example, what we're going to be showing later on today, we call smart road snapping, microassembling, and then, of course, because of Spark, guess what, ladies and gentlemen? You can start adding machine learning, because I have to say machine learning, right? Because if I don't say machine learning and AI, then I'm not hip and cool, right? So now that this word is out of this vocabulary, right? So if you want to do it, go ahead and you can do more stuff with that. Okay? Next. Like I said, you do not have to program any of that stuff. If you want to program it, that's fine, but typically you do not program. You build something we call a HOCON, and you Spark submit the job with the jar, and you pass in a HOCON file. A HOCON file, HOCON stands for Human Optimized Configuration. And you can look it up, HOCON, right? It's a JSON type of structure, but it's more simplified, and we're going to be spending a lot of time on HOCON. So that's what the HOCON looks like, ladies and gentlemen. So, by the way, we're starting the vector down, the dive, okay? We're starting the dive. So that's a HOCON. You all programmers, correct? This is a dev summit, so if you all can't read this, please leave, okay? Seriously, if you cannot read this, please leave, because this is where we're going to be for the rest of the day, okay? This is a HOCON file. It defines a source, processors, and sinks. So what is this doing? This is doing a spatial join between crashes and roads. What I want to do is I want to find per road segment, right? Per road segment, I want to find how many crashes that are happening in there. Typically, ladies and gentlemen, what we end up doing is we end up splitting a road segment into 100-meter segments. And then based on the 100-meter segment, this is what we start associating aggregation. And that is what gives us what is happening per road segment, right? Because if you take a highway all by itself, one polygon, you snap to it, well, it doesn't make sense because it's very geographically weighted, right? There's more accidents happening closer to the intersection than further out, right? So if you have a highway, well, it doesn't make sense to snap and color code the whole highway that way. So typically what we do is we take the highway, split up into 100-meter or 5-meter, whatever it is that you need to do, and that is where we start snapping this. So what this is saying, so I have a source named crash, right? The data is a text file. It is sitting in HDFS, in this file, the CSV format. Now, when the data, the geometry, remember, it's building up an attribute, right? It's building a feature. The feature has a geometry, and the geometry is XY. By the way, if you don't specify where the XY value, it knows how to go to the last two columns. It knows how to go to the last two fields in the CSV file, right? So we made a lot of kind of little assumptions like that to help us out. The roads data is, again, is a text file. It's sitting in HDFS roads.wkt, and the geometry is in WKT format. So it knows how to read WKT, and the other one knows how to read CSV. Now we have a crashes and roads. So what we want to do is we want to do nearest coordinate. So basically find the closest first coordinate and snap it to it, right? So you tell it, use that processor, right? Yes, I know it's very long, but that's what we have to do. And then you can tell it what you're going to take. You're going to take crashes and roads, right? And then the snapping distance is 25 meters, and then I'm going to talk later on about what a cell is. We'll talk about what a cell is. Process, where you want to put the data. In this particular case, I'm syncing it that text in an S3 form, in an S3 bucket. Okay? So you can imagine, you can run this on Amazon, right? You can dump it into, if you have an Amazon, you can go to an S3. By the way, S3, something else, by the way. So S3 is not synonymous with AWS. Okay, everybody, I want everybody to understand this. S3 is not synonymous with AWS. It is becoming such a powerful API, it's becoming such a powerful protocol that certain disk vendors and some hard drive vendors and stuff like that are starting to implement that natively, right? So typically what we see like, for example, NASes, you know what, network array storage, right? These guys have multi-temperature storage environment. On top of that, they can have multi-protocol way of reading data, right? And in that protocol, they can expose HDFS, S3, and all these things. And that is making some amazing scenario in there, right? So first drawing of the day, picture 5, right? What you'll end up seeing is a NAS, multi-temperature, right? This is the temperature stuff. This is what we call hot. So this is typically SSDs. This is warm, if you want to think about it. These are hard disk drives. And on top of it is the protocols, right? And in the protocol, they have typical file, right? They have NFS, right? And then they have HDFS, for example. And also they can put in S3 protocol in there. So the same data, depending on where you want to put it, you want to put something that needs to be accessed very quickly, you can put the file right here. Or depending if it needs, I don't care about it, it needs to sit in lowercase, I can put it down there. But the same data can be accessed by the appropriate compute power on top. Right? This is the compute power on top. Based on their capability, it can access it accordingly. So what we love to see, for example, is HDFS and S3. Why? Because those enable parallel distributed reading, right? And so this is what we're seeing a lot now, ladies and gentlemen, happening. And they throw in a very fast bus in here, right? This is the bus, the data bus here, the network bus. They put in a very, very fast network access from here in such a way that now, depending on the compute, we can do amazing things in there, right? So this is where, for example, your Spark can sit, right? And then you can put in, for example, Pro, right? In here that's accessing the data through the file protocol, but then the Spark is coming in and reading the data through the S3. Right? So same data accessed by different people based on their protocols.